Okay, Science 10 people, we're going to look at the Blackline Master 9.5b average speed exercise 1. With this assignment, we'll actually be going through some calculations, seeing how that V equals D over T formula works, and figuring out speeds of various Olympic runners here. So the Canadian records for running as of December 1st, 1999, so the assignment's a little bit old, are listed on the table below. They're taken from the official website of Athletics Canada. So if we take a look, we have it broken down into men's events and women's events. So 100-meter run, 200-meter, 1,000-meter, and then women 100, 200, and 1,000. So we have times and seconds, and we have the distance in meters over here, depending upon how far they ran. And of course, different winners from different countries, etc. So we'll be looking at figuring out speed in terms of meters per second because those are the units we have. I think the question at the end there looks at who is the fastest runner overall and then convert that into kilometers. So how many kilometers per hour can one of the fastest humans on the planet actually run? So, number one, calculate the average speed for men and the average speed for women when they each set the Canadian records for the following races. So these are record-setting times. State each answer in the correct certainty in units. We're not going to worry about that too much in Science 10. When you go on and take physical science, we look at that and look at uncertainty. But for here, we'll not pay too much concern for it. So 100 meters. So we'll look at the men and the women. I'll do that one with you, and then I'll get you to do the 200 one, and then the 1,000 one on the next side, and then use the final answer to figure out who was the fastest, and then use that 3.6 calculation to convert it into kilometers per hour like we did on the average speed handout that you should have. So we'll look at this. So first of all, let's set it up here. So for men, there's a tie here. So 100 meters is done in 9.84 seconds. So basically, same calculation for both people. So we do know D, we do know V, so we could do this off to the side. D is equal to 100 meters. Time is equal to 9.84 seconds. And then VAV is the big question mark. We don't, that's what we're actually asked to find. And it's a good habit to get into doing that, especially if you struggle with trying to figure out what you're asked to find out or what you're given. Look at the question and pull all that out. So VAV is equal to change in D over change in T. So 100 meters is the distance, 9.84 seconds is the time. So if you put that into your calculator, you will get 10.186 for numbers. And to find out the units, we have meters on top, seconds on the bottom, meters over seconds, or meters per second. So the word over, change it into per, and we get 10.16 meters per second. So 10 meter sticks in 1 second. That's really quick. If we look at the women here for the 100 meter, Angela Bailey here, the time is a little bit longer. And once again, off to the side there, I should look at, okay, the distance she traveled was 100. Her time was 10.98 seconds, and V is the question mark. I should write that over there, but I think you kind of get the idea just by looking at this one. So, again, she went 100 meters, and her time was 10.98 seconds. And if you put that in your calculator, 9.11 meters per second, I believe, is what you get. So she's a little bit slower. 9.11 meters per second, whereas the guy is 10.16 meters per second. So the 200 meters is calculated the same way. When you get to the 1,000 meters, of course, it's a longer distance, and the time unit is given in minutes and then so many seconds. You have to convert all of that into seconds to make it work. So 2 minutes, 16.88 seconds. I'll maybe start you off and set you up with that first and to show you how you do it. So with this one, the 1,000 meter, if I look at the men, once again, we're going to figure out the men and the women. So over here we have 1,000 meters. And if I just work out the guy's time here, Graham Hood, 2 minutes, 16.88 seconds. 2 minutes and 16.88 seconds. So we should change that into seconds. Of course, 1 minute is 60 seconds. 2 minutes is 120 seconds. So I'll just change this to plus here. Plus 16.88 seconds. So in total, that works out to be 136.88 seconds for time. Combine that minute unit and the seconds unit into seconds entirely. And then, of course, VAV is what we're asked to find there. So I did that for the men. Once again, same calculation here. You do the same one for the women and see how you make out with that. And then the last question here when you get to it, by looking at all this data, whether it's a 100-meter race or 200-meter or 1,000, who is the fastest person in Canada? So you just simply say, tell me who it is, and the name and the speed in meters per second. The interesting part, of course, is convert them to something that we know, kilometers per hour. We're used to dealing with kilometers per hour, so convert your answer into that unit. So I'll give you some time to work on that now. Complete all the blanks there. Make sure you copied out the questions that we worked together on.